I feel like we should have done this in Google Meet to begin with. I feel like that would have been so much easier. And we
I
always,
think it was just like, oh, Discord, you just start a voice chat and you do all those things. But
yeah, I know. It was like, oh, the community's there, it'd be easier. But like, honestly, the features here between like recording and transcription and like the video resolution of the screen share, like, oh, we should have just probably done it to begin with. Oh, Sejal, good to see you.
Hello. Yeah, nice to
Nice
be
to-
here. I just saw the link and I was like, yes, let me go. OSO, I love
Awesome.
OSO. You guys are amazing.
oh,
Oh no, love the work that you do. I'm so glad you could join. Cool. Okay, well, demo day. Demo days, just as a recap, a couple new faces here. We do these every other Tuesday to kind of wrap up the end of a sprint, celebrate the birth of a new sprint, and just kind of demo the stuff that we've been building together. We have a really packed, agenda. So maybe we can start, just in the order that we have written down in the doc. Rohit, do you want to start with some of your grant analytics?
Yeah, sounds good. Yeah, I had 3 topics, but I think I can cover 2 while I'm pulling up my screen. One thing that's common across both of these is they are insights that we've shared with our partners. The first one is with Octant. So just a quick context, and hopefully the dashboard's coming through by now. So
Not
quick
yet.
context.
Are you
Not
screen
yet.
sharing?
It's highlighting on my end that it's shared.
Oh, I
it
see
is
it now.
starting to share. Yeah.
Okay, I see
Oh,
it now.
there it is.
Oh.
Oh, cool. Yeah.
Just a bit of lag. All right. So quick context behind this effort. We have been a grantee at Octant, for the longest time. So this was our sort of effort to show Octant the grant analytics for the calendar year that for 2024. So this has data for 4 of their epochs. Each epoch lasts like a 90-day funding cycle every 90 days. So this has data at different levels of granularity, starting from grantees to comparisons across epochs to doing some rankings across epochs, and then finally some forward-looking findings based on the data that we were able to capture for the 47 out of the 62 open source grantees that Octant has. I know we are tight on time, so I'm just going to gloss through some of the key sort of tabs here. I won't go through every tab. Let me go to one interesting tab here, which is top projects by epoch. And this is the most exploratory view that we built for Octant and essentially for everyone in the community as well, where you could create your own composite metrics on the fly and then rank different projects in every epoch. I'm going to take a quick example here. The one that's default, that's set up here, is we're looking at commits and pull requests. I am weighting them equally half and half to create a composite metric, but there are other options that you could pick here. Number of times the repo was forked, if you want to focus more on popularity as an example. And then once you set the weights to 100, you essentially get a custom ranking of how different grantees did in every epoch. All of these rankings are normalized by the team size. So this makes sure that no matter how big or small each grantee is, there's normalization based on your team size. And then you also get sort of a across epoch view of how the different projects have consistently done or not done after every epoch. So in this case, the takeaway is based on commit counts and pull requests, like Rotkey, across most epochs tends to be higher than some of the other projects. But you could equally flip these metrics to focus on popularity, like based on stars and number of folks, and you will get a different view. Again, there is no right answer, but this was an attempt to give the audience the tools to sort of create metrics, composite metrics on the fly, and then slice and dice the data. And the last one here is looking into the coding metrics. We applied clustering algorithms to sort of group grantees together into categories that could eventually lead to a multi-mechanism funding. So I'll take one example here. These are all of the 47 or so open source grantees in Octant, and you will see they're clubbed into different categories from early stage to high engagement to mature projects. This was done by capturing their last 6 months scoring metrics, and you will see sort of some organic grouping here. The idea to do this, or the way to use this data, is to know that each of these projects and grantees, based on their life cycle, have different needs for their funding. And by grouping these together, often in their V2 that they're launching, could now target some specific unique allocation mechanisms, direct grant versus retro versus QF, based on what these cohorts are.
So how did you define these cohorts? Oh, okay, I see.
Yeah.
Like, were these manually bucketed, or did you use metrics to kind of auto cluster?
This is entirely automated using like data and underlying metrics. So this is slightly the more technical view once I sort of
cool.
collapse the cluster into 2 dimensions. So this was done looking at the per developer productivity along with some other characteristics, like when was the first commit. Like some of the OG projects tend to go hand in hand together based on just when the project started. So everything around the developer metrics and when the project started and the development velocity, all of that goes into defining that. And as you glance through the names, I think there is some organic mapping that you can just realize based on anecdotal data. But the intent is also that to prove that this is data driven. And if you want to tailor allocation based on these groupings, now you can back it up with data as well.
That's super cool. Is this an awesome OSO? It totally needs to be if it's not.
I can add it. Yeah, this is one of the more recent ones. Yeah, I'll add it. But we have a blog piece to go with it. The Octant team is reviewing it. Yeah, we want to put it out there before the Epoch 6 allocation window ends. But yeah.
And you already did your feedback session with Octant, right? Could you relay any information that they shared during the feedback?
Yeah, not everyone could make it. James was present, but Artem couldn't make it. So they are just reviewing it, async. We were able to record the meeting and send it to the extended team.
Got it. Anything to highlight or anything? Anything that stood out in terms of the feedback?
Yeah, we didn't really get a ton of feedback from James, but I think they are definitely scaling by launching Octant V2, which is much larger than in scope than what they do today. And this was a point of view that they were internally debating in terms of if we were to separate projects, there's going to be a qualitative like bias based on which project goes into what kind of cluster. But this is somewhat more quantitative and data driven. So if they were to adopt this, there is data to back up the decisions as well, versus someone saying, hey, this project is mature versus this is early stage.
Super
All right,
cool.
I think I'm about time. I'm happy to like pause it here and hand it over, Ray.
Yeah, I put are you comfortable going next, Evan? Because I feel like both of you guys have built some really interesting dashboards, and I feel like one follow-up question that I have for both of you is like, yeah, like take a look at each other's work and see like what's common, what's different, and like is there anything from these 2 dashboards? What I really like about the ability to do things in Streamlit, Hex, what have you, is that it gives us the ability to prototype things really quick. But I'd love to like extract those into learnings of like what are the repeated things that we want to try to build into the product or into production models.
Yeah. Specifically for this one, I had to do some custom calculation to do metrics aggregation at the windows that the Octant runs epochs for. But I think with SQL Mesh and time series, it will be much easier to do versus what I had to do starting last month. So I think it's already baked into the product if we were to repeat this next time.
Cool.
Yeah.
Evan, you comfortable going next?
Yeah, definitely. I can share my screen.
Thanks, Evan.
Yeah.
Yeah, this is awesome. Thanks, Rohit. Super cool.
Yeah.
Okay, can you guys see my screen?
It's coming through.
I'll give it a
Yep.
second.
We're good.
So yeah, and before I get into this, I'll go similar to Rohit. I'll go pretty quickly and just highlight the key points. But I presented this to the Optimism team last week and got a good amount of feedback about additional metrics that they want added and little tidbits here and there. And so I'm currently working that on my local. So this is not fully updated, but I'll just show you what I presented to them. So I was doing the performance analysis on season 6 growth grants for them. And so the main idea here is that you can select the target project that you're interested in, and then see 4 different main types of metrics. And so first, here I selected Alchemix. First, you can look at just a high-level overview of the project. You can go to the actual grant. You can see basic things like when the grant went out, if they've actually received it, and when they actually received it, and the relevant addresses that were linked to the proposal. Then you can get into more of the core metrics page, where you can select any of these, what I consider core metrics, as well as what addresses that you are interested in viewing. And then you can see over the date range that you set, you can see trends of just how the data unfolds. I have little KPIs up here too that adjust. So as you change the dates, this one here, it just shows the total since that starting date. And this will show the last date when compared to the beginning. You can see when the grant date occurred right here. And then you can just get a pretty simple high-level overview of, okay, transaction count or active users or whatever it is, how can we understand that over this time period? You can also really drill down. And so if I'm interested in looking at like just the wallet addresses, for example, or just contracts and vice versa, you can actually go in and see each individual address and how it unfolded over that date range as well. And then the big thing that they wanted me to add here, which is already done on my local, is I normalized all these metrics by the grant amount as well, so that they can compare that project to project. Then next we have TVL. So this is for projects that have an associated DeFi Llama protocol. This one has a lot more visualization, so I'll go pretty quickly through this, and then if there's anything that stands out, feel free to let me know. But the main thing here is just comparing TVL post-grant to pre-grant. So here we can just see, an overview. You can actually get pretty detailed in to look at things by token as well as by chain. So if I want to look at like all optimism tokens, for example, it'll select them and then I can actually look at that there. Or I can get into like, I'm not too familiar with these different tokens, but I'll just select random ones. And you can actually go in and like select, and really just customize it to how you want it to be. Next, we have the TVL distribution across chains and then across tokens. So same idea, just a high level where you can get a quick glance at pre versus post grant and how things are distributed across each of these. And then finally, on the TVL, we have visualizations related to relative daily changes. So first, this is a distribution of the relative daily changes in TVL, again, with pre and post grant, and a little box split up here so you can actually compare distributions and see how they differ. I then have a line chart that shows the same thing, but over time. So you can get more of a, high level like time approach. And then finally, volatility by chain. So you can select which tokens you're interested in, and then see for each of the chains how the distribution is spread as well. And this is, daily changes in TVL. So how stuff changes day over day. But yeah, so that's TVL. And then finally, I have the statistical analysis section. So similar to the idea that Rohit had, the main goal here is to really put the power to the audience and allow them to kind of quickly analyze the data on their own. So you select, again, the target metric that you're interested in and your date range, and then you'll see 2 different mechanisms of comparison. So first, I used, here, I'm going to adjust this date range so the data looks a little bit better, but I use synthetic control methods to forecast a post-grant period, which you can then directly compare to the actual post-grant data. Here is a little blurb where I talk about how I did that, but I did it using a Surima model for some metrics and then a linear regression for others. But yeah, so then when you actually go in and if you select TVL, for example, you can also customize how that data is forecasted because there's obviously different needs. And so you can either by default, it'll forecast the data based on the pre-grant trends, or you can go in and actually forecasted based on like the OP change trends as a whole. And then you'll see how that data changes, because obviously we saw huge growth across the chain as a whole. Then down here, and this goes hand in hand with that, I wrote something where you can conduct your own 2-sample t-test to actually statistically analyze how the data changed over the 2 periods. And again, I have a little blurb explaining what that means for people that don't know what a 2-sample t-test is and what each of these metrics mean. But you can select what you want to compare the data to, whether that's the forecast data or the pre-grant. You can select your alpha value, which again, for people that don't know what that is, I put a little thing here that helps clarify that. And then you can actually see the results of the t-test, where for pre and post grant, you see the sample size, the sample mean, and the standard deviation. And then I wrote a little conclusion so that if you aren't too familiar with this and how to actually understand the numbers, you can just read this and it's readable. And you can see, for example, here that we reject the null and conclude that the grant likely had a measurable impact on TVL. And it shows our confidence level in that conclusion. And then finally on this page, we have then I have the actual distribution that shows, again, this is how to interpret it, but this shows where our rejection region is based on this alpha value, and then you can see the test statistic. And I explained in this blurb as well that the further the green line is away, the more statistically significant the data is. But yeah, so this is the statistical analysis section, and there's a lot. You can do that with all these metrics. You can customize this date range, and then it'll rerun the test on the date range as well. So there's a lot you can do there. And then the last thing, after you've analyzed and explored each project pretty individually, you can then go look at the high level of all the projects. So this is designed to be more for like the Grants Council, so you can select what that alpha value is and then see for each project, the basic metrics, as well as if there's increase or decrease or no change over the period. And then I have some just basic scatter plots on the bottom here, as well as a distribution, but I'm realizing I think I went a little long. So I'm going to pause there. But yeah.
Awesome. Wait, I'm curious, who's seen this before? Rohit, Ruben, have you guys seen this before?
No, this is awesome. Yeah.
You're muted.
Yeah, this is my first time. This is pretty neat.
Oh, cool. Awesome.
Yeah.
Aggregating new fans, Evan. Yeah, this is super cool.
A quick question, Evan. I think
Yeah.
the amount of the kind of insights are like massive, and the more eyes are on it, the better. Do you know if Optimism has plans to make it public to like the community?
I'm not sure, but I believe they hinted at that the last time we met.
Okay, yeah, that'll be awesome. I think the more eyes are here, because there's a ton of things you could do and do more narrow analysis on your favorite projects.
Yeah, exactly. That'd be pretty cool. Cool. Anyone else have any other questions?
I think, well, we can schedule some time afterwards, but it would be cool to see, of the not just the DeFi Llama data, but any of the other data sources. Like, what are the things you had to do in the back end? Is there anything we can add to the production pipeline that would make your life easier so that you don't have to, crawl this data yourself, that kind of stuff? But yeah, this is definitely an awesome start.
Cool. Yeah, I think that was the main thing. Carl wanted for me to like walk through my actual code and show you guys so that we can work through refactoring it.
Yeah, awesome. Where is everything again? Sorry, it's in Insights, right?
Yes.
Is that correct? Okay.
I have like a little folder in there called Streamlit Dashboard. I can send that to you as well.
Cool. Yeah, that'd be great. Yeah. And
cool. I tried to make everything like really neat and commented and everything. So hopefully it'll be easy to find.
Yeah. You've already done better than me. So it's I'm a high output, low documentation for a while now. So I am trying to go the other direction. Yeah. So
here that is for anybody interested.
All right, Javi. Thanks.
Hello. Can you see my screen?
yes.
Yeah, that's good.
Yes, well, I'd like to start with something that happened some days ago. So basically, we had this failure at the end of our pipeline, which was pretty upsetting. So I want to start this demo day by saying that I am working on a way to make DLT more resilient, which would enable us in the future to be able to, for example, skip data we already materialized. And if this happens in the future, we don't have to wait 26 more hours. So this run is actually the root of me finding a bug in the SBOMs, which was a little bit, it was pretty here, and actually I spent some time on it. And now we have way more SBOMs, as in, I think it is we have now 5 times the sample size of repositories. So all the SBOMs have grown exponentially, which means that you have way more data to do analytics, which is pretty cool. And then this is the run, which succeeded after that. So next thing that I've done is the SQL Mesh key metrics. So what are the SQL Mesh key metrics? So the key metrics in SQL Mesh are basically a group of metrics that we pre-compute, or for example, all of the span of time. Imagine if you want to know all of the commits that have been done for a project or a collection or an artifact over all the span of time. If you were going to use our current models, you'd have to use someone that's, for example, a view, and then it would cost a lot of money. It would be slow, inefficient every time you need it on demand. So that's why this exists. We run this periodically, or we will run, and then we will serve you that data. So these are done with SQL Mesh, and as you can see, there's a lot of magic behind, but each of these is pretty simple and pretty small. And thanks to Ruben and his magic, the collections, the project, and everything get wired up from it. So how this works is that you create the metric for the simple unit, which is an artifact, and then everything with some joins will get built on top of this. This will power some dashboards in the future that will show you all of the key metrics. And I'm working as well on an aggregated source in order to have everything in the same place for the front end to have it more comfortable. Another thing I wanted to show, which I'm pretty proud of, is the REST API. So over the past, we've had to write a lot of DLT connectors, custom DLT connectors. Yes.
Can I ask a quick question about the key metrics?
Yep.
So the way that these are manually implemented right now, right?
Correct.
Each key metric is manually implemented, and you're using the factory predominantly to do the entity level aggregations. Is that right?
Yep.
Got it. And so without that, we would have had to, I guess, manually translate the entity aggregations, but otherwise.
Correct. Yes.
So
yes.
I guess basically what I'm trying to understand is the things that we currently have in on-chain metrics, and code metrics by project in DBT. Basically, you would have to add. You would basically have to translate it to this kind of structure to make it work.
Yes, you would have to translate it to the smallest unit. And then with the factory and all the logic implemented, you will build the two projects, to collection, to everything.
And what would be the difference between this and a time series metric? I guess basically in a time series metric, you might be defining rolling windows or something like that. So then you are adding those as set. Let's say, for example, I had both a key metric for active address count and a key metric and a time series metric for active address count.
Yes.
I would define those two things separately and then have one just aggregate by entity types, and then the other one aggregate both the rolling window and by entity types.
Yeah. So this is something that we had discussed. We do want to make it so that both of them would basically be defined from the same model, but that required a little bit more changes in the factory itself. So eventually we could just have an active addresses type or model, and then that would give you overall time and or over rolling window and or over some kind of normal aggregation.
Yes, there's some small differences. For example, for the metric sample date, instead of putting now, you put a special macro that will inject you the time that's, for example, in time series. If it's, for example, from this period to that period, it will get automatically there. And then here I'm doing overall time, so I'm not doing any filter, which we have special macros to create these time series, which will inject the correct time range. So that's some change that had to be done at the factory level, and Ruben and I decided to do some separate models in order to get up to speed and shift this fast.
Okay. Like, I guess that's a fundamental question I'm asking. Like, is it desirable to have it be defined by the same model, or is there reasons or edge cases why it's like important to keep these things separate?
I feel like it's desirable only because a lot of these are basically the identical, minus like a date filter, right? And so you could even keep the date filter and then just have the thing be smart enough to literally use all time that we have. So in data. So yeah.
Got it. Is there an issue to track the
Let me double check. But yeah, yeah, let me double check. There might not actually be. I may have forgotten that.
Okay.
There is not.
And if you had to cost that issue, like how complex is that? Like, because
that's like that's maybe 2 days. Like yeah.
yeah.
I mean, like yeah. That kind of change I would like to make with Javi though. Like I would like to do that one together. That way we can dive into the factory because yeah, I think it's a good significant change. And it's a useful one that reduces the code, duplication quite a bit. So
okay, yeah. Do you mind filing the issue and scope it into the next sprint for now? I don't know if we actually want to do it in the next sprint, but that way
yeah.
Keep track of it and we can chat about it during planning. Cool. Sorry, didn't mean to interrupt. Thanks.
No problem, Ray. Next thing I wanted to show is the REST factory. So over the past few months, I've been writing a lot of custom DLT connectors, which in the end, they all boil down to the same thing. You have to fetch some data from endpoint, and you have to do some transformation. So we created this REST factory. So how does it work? So basically, this REST factory is just a wrapper of the DLT REST API source. And it also enables, it also uses all of our custom logic for like Dagster assets, which means that it uses the DLT factory under the hood. So if we do any change to the DLT factory under hood, we inherit that here. It is pretty simple to use. You just need to pass this config object, which tells you, for example, what's the base URL of the endpoint. I want to have, for example, this primary key or this write disposition. And then for the resources, you pass an array of resources, which is like the endpoint, which is just the string endpoint relative to the base URL, and some data, for example, data selector of the dollar selects all of the JSON. If you want to have, for example, there's a subset, you put the JSON path. And then you just need to create the REST factory asset. And here you can pass the configuration itself. And you will get this DLT asset function, which is the configuration for the DLT factory. So for example, here I'm only passing key prefix, but I could pass all of the configuration that you can pass, like the OP tags, for example, if we want to set tags for the OP, or like the tags for like the Kubernetes job. So all the configuration is done here. I actually spent quite some time doing this type safe, so it is fully typed. You can there's like no any's, no nothing. It's fully typed, so you can actually see like all of the configurations that you can do. And in this example, I fetch all of the DeFi Llama protocols, and I have this helper function, which basically just makes the replacement of like dots and all these characters. And the only thing I have to do is I have to map through all of the protocols, and I just say, hey, I want this resource, and that is the endpoint. And by doing this, basically 20 lines of code, we are able to replicate dynamically all of those assets. This is the REST version. I'm actually working as we speak in the GraphQL version, which basically means that we can deprecate quite a lot of code that we have, for example, for the NPM connector, Open Collective, Ethereum attestation, and I've done upgrades, which means that we don't need to anymore, for example, for the Open Collective ones, set all the data we want. We can just say, hey, take all the data up to 5 levels of nesting, and everything's automatic, which is pretty cool in my opinion. We reduce a lot of code, and we are able to onboard new people by just like setting a new config, a new endpoint, and you're ready to go. We don't need super engineers, just people who are able to read the documentation, and they'll be able to contribute, which is always exciting. Here I have the REST API source. So basically, this is the full configuration. If someone wants to contribute, they can read this guide, which is actually super useful. It walks through you through an example of how to set one of these. For example, if we wanted to clone GitHub, we have to set the endpoint and the token, and then we set these resource defaults. And the cool thing is that you can add a lot of like configurations, like, hey, I want to get this date or I want to get these params. And there's like built-in paginators. So if you want to have, for example, a JSON link on the URL, so everything's handled out of the box. It's just ready to be set in the configuration, which makes us go even faster. This is the code from the factory. A lot of nesting. I need to refactor that with the thingy you told me the other day, Ruben. I have it on my notes.
Mhm.
And the last thing I want to show is the deep funding share it application I've been doing. So this small application takes your submission, for example, an initial submission of their weights, and it renders a graph. So I've updated it since the last time. So basically, this is the one I will share. And here are all the clusters of all the comparisons that you have done. And you can go, for example, to this one and say, okay, so let's say I'm comparing, I gave a weight to Bubble, which is compared with floating UI, and these are like all of the ones you compared. As you can see, all the weights are the same, but this is because the test file has all of the same weights. But in the future, this will have different sizes, and some of them won't be even there, which will allow people to actually see where their prediction is going, and you will be able to like interactively see how it is. You can make this bigger as well, and you can actually save this as an image if you want, and everything is rendered dynamically. So this will be used by the Pond people. They will put this in the description probably of like the contest, and they will say you just have to like just have to append here the URL parameters. You put URL and the URL. It will actually render the one from there. Which makes it super easy to use for them. They don't have to host anything, and everything is rendered pretty cool with like Cosmograph, and that is how you can explore the graphs.
Sorry, this is to visualize the predictions or to visualize the training data?
No, this is the predictions. So basically, this is like an example submission file that I have been given by the Pond team, but they'll have the same weights. So everything's like 0.5. That's why they don't have different sizes. If I change the size, for example, imagine this node will be like 3 times big as this one. So you can see for each cluster which prediction you gave, and then you can tweak it and you can see it manually. And that's how it works.
I guess I'm intuitively I'm trying to understand why they're like this. It currently has pockets. Like, wouldn't the predictions be much more connected?
Yes, the thing is that, okay, so this is just connected. I have, okay, so all of these purple nodes, which is like I'm taking it as like the root ones, are the project A. So in the sample dataset, we have project A against project B. So each project A is compared against a lot of project Bs. The thing is that if all of them are nested, the graph doesn't show anything because it's just like a big mess. There's like not any, how do you say, there's no value that adds. Everything's connected with everything, and there's a lot of noise. So by doing this approach, whenever people actually submit their folks, they will say, okay, let's say I want to know my prediction, like how much weight did it give to this comparison. They can go to like the root node and find, okay, let's say, for example, I want to find floating UI, and they will see all the ones that have been compared, and that's how they can see like the size they have given. And that's how I framed it. In the past, I had all of like the comparisons were just A to B connected, and I just gave the size to like that comparison. The Pond guys told me to change it to something like this, so that's what I did. But if we don't see that this has like provides enough value, we can like roll back to the other version. We still have to see with like some real training data, and it's just we have to test. This is just like a visualization for demo purposes.
Cool, awesome. And it's backed by Cosmograph, so this is just kind of like a shell on top of Cosmograph in some way.
Yes, so I'm using the React components. Actually, this is like the repository. If you go here to like the islands and then you go to the graph, basically I have, yep. So here's the main graph rendered. I pass all the nodes. I have some custom logic. Yeah, everything is done, is built in-house. I've done this from scratch. So it gives us like all the customization that we want.
Cool.
Thank you.
One follow-up question.
Yes.
On the thing before, I think Evan, you have been playing with the DLT REST factory already, right? On the DeFi Llama data, or you've played with that, tried with that before?
Yeah, yeah. Javi was great with helping me figure that out.
Oh, okay, cool, awesome. Yeah, feel free to. It sounds like we're in the process of connecting. I guess Ruben can demo next. Process of connecting the OSS directory to this thing, right? Have we already made that connection between the OSSD, DLT connector and feeding this DeFi Llama fetcher?
So OSSD and DeFi Llama stuff aren't connected, just the DeFi Llama thing. So I can show you, yeah, actually what I've done. So let's just do that. Right. Here we go here. Okay. Yeah. So yeah, so with the updated SQL mesh models that we have for DeFi Llama, everything's in staging or intermediate. So in the staging models, we actually use a Python model in order to process things because some things are in JSON. So we actually have to put it into data frames and do some magic here. So we split that into the time, the protocol, the chain, the token, and the TVL. So there's no filtering done here because we don't have the OSSD data at this. We're just not doing it at this stage.
Are you screen sharing right now?
Oh, is it not showing up? I am supposed to be. It told me it did.
Can anyone else see it?
Oh,
okay, I see it. Cool.
There we go. Okay, cool. Yeah. So, where was I? Yeah. So you look at the staging models. We do DeFi Llama as a Python staging model. We process some of the JSON here that we have in these values. This both executes on DuckDB and on Trino. It's already been tested there. So that's cool. Yeah, we don't yet do any of the filtering we have with what we get from OSSD. So the way that we feed the DeFi Llama, like what the sources are based on the DeFi Llama protocols that we had just as a constant in the OSO Dagster assets DeFi Llama. It would be simple enough to be able to take, like some what do you call some other input here, so we could use OSSD as the input to this. So the Python
I think you could make that a query or something, right?
Yeah, exactly. So that way yeah, this all gets generated. These are all generated right now. I thought about actually connecting it all into a single model because it's small enough. So perhaps we will just do that. But for now, everything is generated as a completely, like it's a factory that generates completely separate DeFi Llama models per protocol. And one of the benefits of doing it that way, at least, is, right now, if we were to delete, like, or, if these things are constantly getting added and deleted, then you'd have to be constantly recalculating the same one all the time, which, probably isn't ideal. So, yeah. But that is the DeFi Llama stuff. Oh, yeah, sorry, the intermediate.
Did you go any further beyond the staging model?
No, we have the intermediate, or yes, we have the intermediate models,
cool.
and these get turned into events. So these can be joined at the event level. They are not currently joined at the event level because I didn't want to trigger a recalculation of all metrics. But yeah, if we do that, we can also join all of these at events. So do we have int events here actually now? We do, right? Okay. Yeah.
Yeah, I'm currently in the process of refactoring this, but yes.
Okay. So yeah, so you would just,
yeah, you just
union that. Yeah, you can union that here, no problem.
Cool.
Yeah. So all the DeFi Llama staging and models are all ready. So the only thing that we need to do again is for every we just need to integrate OSSD DeFi Llama stuff. The Python OSSD library, that's up to date with DeFi Llama.
OSSD library with DeFi Llama. Yeah, I can demo that next.
Oh, cool. Yeah.
Wait, no. Sorry, the DLT connector.
No, not the DLT connector. So when we parse OSS directory, kind of crazy.
It's in the schema, and it's published to the Python library and npm library.
Oh, okay, yeah. If it's in the Python library, then that's all. Yeah, if it's in the PyPy library, then that's all I would need. Yeah, as long as it's in here. Yeah, perfect. Yeah.
So, do you have to update the DLT fetcher for OSSD to whenever there's a schema change, or?
Yeah. So what we would do is, we would have to update the fetcher to be dependent on, I guess, this. Right now, it's just dependent on a constant. But yeah, we would just replace that. So it could either be done as, after the project fetch, but I don't actually think that's necessary since all of the data that we need for those slugs are already in the library. So you can just import the library and then pull from there. So it's be whatever's latest in the library.
Right? Yeah, by that logic, do we even need the DLT connector for OSSD?
Oh, no. I mean, yes, you do need the DLT connector, but for OSS directory, yes, because we still need to grab all the repositories. So that's maybe the original use case for all of that. But that also uses a combination of the two, right? Of this Python library and also fetching it from GitHub. So with DLT. And then the next thing we wanted to go over is the metrics on the website. We can just go over this quickly. I'm just, very happy to see these here. So anyone who's familiar with this issue, we've been doing this forever. So it's kind of cool that they're there now. Shoot, I was just, hold on. My window is.
I saw Carl's on the call. Did you have any questions about the DeFi Llama event data?
I'm sorry. I'm actually having a very hard time following along because I ran OSO metrics initialize and it's like killed my memory while it's kind of loading everything.
Oh no. Okay.
Anyway,
no.
I'll watch the recording later on.
Yeah, as long as you're on the latest of OSO metrics, the initialize, as long as you're on the latest branch, you could stop that and then it'll restart from wherever it doesn't have any data.
Okay.
So
anyway,
we're a bit smarter. So no, yeah, previously you always download. So okay, so but just recap, I guess, all the events, the TVL events are now in all the way up to intermediate models for DeFi Llama. So I don't know if you caught that part.
Okay, yeah, I caught that. I
Okay,
just had a hard time actually seeing the screen.
I see. Understood. Okay. All right. Well, let's look at open source observer. So some of these metrics. So one of the big things that we made, big changes that we made is to use time series metrics. We created this entire architecture to be able to calculate massive rolling windows and or over all data that we have. There's other videos on how we do that, but we can just take a look at some cool stuff. Maybe we can do full-time developers over 180-day windows. Let's see. This is cool, but obviously it's just us. So hold on. Let's see. Full-time active developers. How about that? Oh God, this search is not as cool as I want it to be. Active developers over 30 days. So what this does is it gets active developers over 30 days, continuously. And so you can see this kind of for all time for us, which is pretty cool. So you can see these, peaks and valleys. We have more other data for, on-chain things. I haven't explored all of this stuff. I'm just really happy that it's all here. we haven't debugged all the data, so there's some weird things with like the life cycles. But this all it's fully end-to-end. It goes from DBT all the way to SQL Mesh, all the way to ClickHouse. So, which is very exciting. Okay, and then the last thing, I guess 5 minutes really was aspirational. I apologize. So,
well, I mean, it's I realize everybody's been rushing through. What I meant was like 5 minutes for you talking, but making sure you allocate breaks for people to ask questions.
yeah.
10 minutes overall. So, yeah, do people have questions? I feel like we're not necessarily making that much space for it.
Cool. All right. So this last one is just about having, so we set up part of actually what Carl's doing right now is initializing a local DuckDB so that you can test SQL Mesh. And then we can also extend this at some point and have this write to a Postgres server so we can do a local Trino. But for now, that's not something that we're doing. Actually, we can have DuckDB do that right to Postgres, so we don't have to do any translation, which is amazing. Yeah, so one of the big changes I added yesterday while I was doing this, because I was looking at the superchain data, is to make it so that previously, Ray, we were doing just like strings in this dictionary. Now I have this table mapping destination. I couldn't really think of a better name for this. But basically, it's just instructions on how to load specific data for a destination. So you can give a row restriction. So right here, I have a start date and an end date. And this gives, and this actually targets a partition inside of, or partitions inside of the superchain data set. And then I also restrict specifically to chain ID 252 because Frax is small. So it's not going to, loading that data is not going to kill us locally. So at least I was hoping it was small. So how small it is, I don't know, but it's smaller than the others. So
wait, sorry, where is start date and end date? Oh, okay, those are variables from before. Got it.
Yeah, these are variables up here. So these are automatically as just like the last 30 days. So that
And
way.
what is DT?
DT is so yeah, these are from the model itself, from the Optimism on-chain.
Oh, okay, yeah. So you're basically specifying a where clause here.
Yep, exactly. So the row restriction is a where clause. A row restriction is what BigQuery called it. BigQuery's API called it. So I tried to keep it the same.
Cool. Very cool.
Yeah, and that's it.
Awesome. All right. Any other questions for Ruben? Cool. I will try to be quick. I think, good number of you have probably already seen some of this, but in OSS directory, we now have, the ability to pass in DeFi llama slugs, and I just added a quick validator to be able to do that, which I think Evan has been using, it looks like. At least, did you have any questions on how to use this?
Nope. This looks good.
Okay. Yeah, I think the main thing is you got to remember to use a comment command to start the validation. So you just pass in the SHA commit, but otherwise it should auto-populate. And it will do two types of validations. It will just check one, that it's like a well-formed URL, and then the second one actually pings the API according to Javi's instructions to make sure that it's a valid slug. So this will help catch bugs as we're fetching data in. And then it sounds like we still need to wire up the OSSD with the DeFi llama data collector on the other side, but hopefully that's not too hard. So yeah, that. What's that?
Right now we just have support for protocol slugs, right? If you had like bridges or tokens or other things that call a different API endpoint, we don't support any of that yet, right?
Yes, it is only calling the protocol endpoint.
Got it.
Yeah, if there's other needs, feel free to add it. I mean, the part that took the longest was the restructuring of the GitHub app. So hopefully any new things shouldn't be too hard. Cool. Yeah, and then this, I'm sure some of this stuff Carl has already seen, but in case Evan is interested, or this is, we also have the ability to write Python models in SQL Mesh, which I don't think we've done in a demo day yet. And Ruben was the one that actually cleaned it up to make it work in production. But there are...
Oh yeah, I guess I didn't go over how to write one of these, but yeah, this is a great example.
Yeah, the Open Rank one is probably the best example that we have right now. You'll see that it's predominantly just Python, but the main thing you have to do is add this model annotator and an execute function to create a data frame. So you have the ability to, you know, query stuff from other models, just like you would in any other. Sorry, Carl, you're can you mute? Thanks. You should be able to make queries just like you can in any other SQL Mesh model to fetch data that you need, but then you have the ability to additionally do other types of transforms in Python data frames. As long as you yield a data frame at the other end, it should just be part of our data pipeline. I would probably suggest minimizing usage of this unless absolutely necessary, because our SQL Mesh models, we can parallelize, we can do all sorts of performance tricks on. The Python models right now just run in a single core, and there's no performance optimization, so it will kill the pipeline if it's too big of a job. And so we pretty much only use it for the areas where we absolutely need it. So running graph algorithms with OpenRank is one such example. PageRank would be another example. But yeah, there's a handful of examples where we have to use Python. But otherwise, yeah, try to stick to SQL if you can. Any questions on that so far?
Yeah, no question, but a comment. Yeah, at some point, you know, as if we find the need to do that more, you know, I think we can and could do Spark things. So, like we could deploy Spark, but that's a conversation for later at some point. So
yeah, it's a big conversation for later.
Yeah. No promises, but you know, if it is a dire need, we can get there. So
yeah. And then I just wanted to give a quick update on where we are in terms of like the migration. Like my goal, Ruben, tell me this is hopelessly naive, is to like deprecate DBT this sprint. Like, I want to kill it. I want
I think
and I want to be done with it.
Yeah, I guess this is very like sprint planning-y kind of.
But let me just show you where. Let me show you where I am so far, and then we can talk about this later. So in utils, shoot, sorry. Local, sorry, it's in local utils. This defines the boundary, right? The boundary that I've set so far feels a little haphazard, but hopefully it's not. So for the most part, I try to just go from downstream of staging, but in a handful of cases, particularly around superchain data, where we do a lot of like, oh, for each of these networks, just have like a model that joins, you know, a staging model. In reality, these are staging models, in my opinion. They just join like superchain data sources across a bunch of different places. So anyway, I've chosen this surface for now, and I've been trying to.
I don't think I can see Ray. Can others see Ray's screen as you changed it? Oh, there we go. Yeah.
I only see.
Yeah, I have utils now. Previously, I didn't see that.
Yeah.
My bad. I was sharing the wrong tab.
Yeah.
But anyway, I like at any given time, this is the source of truth of the boundary between DBT and SQL Mesh. Like if you're ever wondering what's in DBT and what's in SQL Mesh, this is the boundary. And so I've defined a rather lengthy boundary so far. For the most part, it's predominantly staging and below, but the multiple handfuls of intermediate models that I've chosen to keep are ones where, basically we still need to figure out how we're going to do the macro of joining data sets across a bunch of different networks. And so this is as close to staging as I could get before, actually diving into that. The one that's mid progress right now is I am in the process of migrating over the GitHub staging models so that I can get rid of this and move that to SQL Mesh as well.
I was going to say that's probably the best because there's not very much macro usage there. So
yeah, it's not. The one thing that's really annoying is parse timestamp is a BigQuery thing, and then what's it called? Something is like the DuckDB timestamp parsing.
Wait, is it like a Unix timestamp that you need to turn to a date or something?
There's just different timestamp functions and slightly different format string, conventions and.
Got it.
Yeah.
Anyway,
forget about it. Like anyway, I'll get it working. But anyway, for the most part, this is where we're at, right? And then everything else, like Carl, this should look relatively familiar to you. Like most of these intermediate models look almost identically the same from DBT. I've gone through the painstaking work of like fixing bugs where I can find them. The types of things that are common that you have to fix are like, okay, making sure you do the model annotation. I am doing most event models incremental by time range now, which is, simple enough. And then anytime you call a SQL function, you have to translate from BigQuery conventions to DuckDB conventions. But that's, that's the whole thing. But pretty much if you look in marts and in directory, this should be complete now. If you take a look at marts and events, this should be complete now, except for the auxiliary events. The auxiliary events, that's in a work in progress PR. And then the last remaining bucket is anything related to metrics. So I want to start using Javi's new key metrics thing to start moving over. Like, I don't want to actually move over code metrics and on-chain metrics by project. Like, I want to translate them into our new key metrics paradigm as I'm doing that. So that's kind of like the next chunk of work. But otherwise, like, yeah, given Reuven's new, I forget what he called it.
The filtering, the row filtering.
The filtering row restriction thing. I'm convinced that we can start moving more of the the staging models as well. But we can talk about that after. Any questions so far about the transition?
I guess more just process wise. Obviously, there's some technical debt that we've had for a while about just models being, there being more models than we need, or them not being like named well and stuff like that. Do you see right now just trying to get back to parity where we have everything that we had in DBT and SQL Mesh, and then we kind of do a bigger refactor and try and make things a bit just kind of cleaner in terms of where they are and how many models we have in total?
Yes. So for the most part, I'm just copying and pasting and fixing bugs. Truth be told, it's pretty well organized. Like, renaming is not hard.
All right, you haven't gotten to my sections yet, then, I guess.
your sections does conflate a lot of things. So you do put intermediate models in like a mart model directory and things like that. But like, that's like a 15-minute, like, we'll just go in and move things around. And in reality, the directory structure doesn't matter at all, because the only thing that matters is the name. And then you can always go in and change all the names. So yeah, all I'm saying is that I think it's not that big a deal. Like, we can clean it up, but that's I wouldn't worry about it for now. But also, the cleanup is not that hard. I don't think it's structurally that bad. I think the main big cleanup thing that I would love to do is, instead of having a unified event table and an auxiliary table, you actually have like event tables per event type or event source. That's a pretty big refactor, because you have to rewire how things are done. But renaming wise, I don't think there's actually that many things that I found that bad. Cool. I know we're like 4 minutes over. Carl, you want to go next?
Yeah, sure. I'll do. I stopped the metrics initialized so I could get some some memory back. I have just 2 things quickly to share. If you've been on our docs page recently, we have some updates. Sorry, let me just pull up the docs and share my screen. So here we go. Great. So yeah, if you go to docs at Open Source Observer again, actually, let's get the original version. We have a much cleaner homepage. And then if you click any of these, it will take you to the right doc. Another one that I just updated over the weekend is the datasets one. So now you have a nice table here, which summarizes all of the main public datasets that we host or have curated. And then if you click on it, you can go down and subscribe or get some sample queries from it. Another thing we have are tutorials now. So one example of these is if you want to map a software supply chain and look at package dependencies. This is a guide for doing that. We have tabs so you can get the SQL. You can also get a Python version that you can copy into a notebook or a Colab. You can go down. If you want to build the deep funding graph, here is the initial code that was used to create that. Again, you can copy it into a notebook and run it. And we've used that now a couple times to make some updates to the deep funding graph itself. So I will show the latest of that. Yesterday, thank you very much, Javi, we pushed a new update, which includes, I think it's about like 6,000 or so more repos. So it was 6,000 more edges, maybe another 1,000 or so repos that were grabbed through that, which is great. You can see all of the stats on what's being pulled right now. So 7,000 packages. Most of it is still JavaScript. We do have some Rust, Go, and Python ones as well. And then if you want to, one of the things that's happening right now is that Pairwise is doing a kind of ranking of some of the most important dependencies that we've kind of curated based on stars and funding and things like that. So you can see the current kind of pruned version for pairwise testing. So it takes the top 30 or so dependencies for a given project, and you can see all of that down here. I don't have a demo of the Pairwise app right now, but if you haven't seen it, you should check it out. It's a pretty cool way of comparing 2 dependencies side by side and determining which one is more valuable. Last thing that I'll share is this Hex dashboard, which is kind of leading up to the retro funding dev tooling round. The way it's going to work is that you will have basically a graph that maps on-chain projects to their dependencies, dev tooling projects. And then there's different settings that you can apply. So we can look at the type of package dependency. We can also look at whether there are shared developers between the 2 projects. Right now, it's a pretty simplistic way of mapping a connection, but we can make things a bit more robust or reputation-based. And then you have different metrics that will be used to weight the importance that each of these nodes has in the dev tooling project. So for instance, if I say all I care about is gas, I can turn down these weights 100%, and then this is running, and you will get an updated version of this where the weights have been readjusted. And this now predicts, based on a limited set of products applying for the round, how much funding they would get if these metrics were used at this level of weighting. And if you want to run your own experiments and different evaluation algorithms, you can just come right here and download the full unweighted graph and play around with your own weighting assumptions. Yeah, and I think that's it. Any questions?
Cool. This was a long one.
Yeah.
I know we covered some stuff that was actually from December because we didn't actually do a demo day in December, but yeah, this was great. Lots of cool stuff.
Excellent. I need to jump, and I will catch up with you guys in sprint planning in 20 minutes.
Okay, thanks.
Great.
All right, thanks everyone. I will probably just jump over back to the gather board for anybody that wants to chat about sprint planning. Yeah, so I'll see you guys there.
That's all.
Thanks.
Yes.
See ya.
Later.